Let's look at this first example. Carlos invests $3,375 in a retirement account with a fixed annual interest of 2.66%, compounded 2 times per year. So a couple of things that I'm going to go ahead and write down. Once I see that it's compounded 2 times per year, let's remind ourselves of that formula. It's A equals P times 1 plus R over N to the NT. Okay, that is something that I expect you to have memorized. All right, so let's go back through our problem and see what information they give us. He invests $3,375, so that is our P. Fixed annual interest rate of 2.66%. Remember, we need to convert that to a decimal, so 0.0266 for R. It's compounded 2 times per year, so that is N. N equals 2. How long? That means T is our variable. T is our unknown. Will it take for the account to reach a balance of $5,575.96? So that is the A. So let's plug that into our equation. Technically, you could go ahead and start plugging into the equation. I just wanted to write it down over to the side to be clear. Okay, so when we plug everything in, that's what our equation should look like. Again, we're not just going to type all the information into the calculator and get an answer out. What we're looking for is the value of T, how long? That's in the exponent. That makes this an exponential equation. So we're going to use what we've been doing. It's just in a context here. So we've got to solve for T. So that means that this exponential expression, we need to get it by itself. Right now, it's being multiplied by the 3,375. So we need to begin by dividing by the 3,375. And we're probably going to end up storing some values in our calculator. Yeah, I don't want to round that. Okay, exponential equations are very, very sensitive, so I do not want to round these things. So I'm going to store that. We can store it as X. It really doesn't matter. We'll store it as X. Now, I am going to write it down right here as 1.625, but I'm just going to put a little note over here to the side that that is stored as X. Now, the reason why I need to make a note is because we also need to store this number, 1 plus 0.0266 divided by 2. We're going to store that as a value as well. Well, that one's not too bad. That's a terminating decimal. We won't store it this time. We're good. If it kept going, I would have stored it as something. Okay, so our exponential expression is by itself. Now we're not used to the base being a decimal, but there's nothing that says that the base can't be a decimal value. We're just not used to that. But that is isolated, so that means that we go to log form. So log, the base is the base of the exponential of the 1.652 is equal to 2. And then to solve for T, obviously we divide the whole thing by 2. So in our calculator, we need to do change of base, log of 1.652, divided by the log of 1.0133, divided by 2. You really don't need extra parentheses here. You could put them if you really, really wanted to, but we really don't need them. Okay, so I'm going to do the log of x, because remember that was the number that was stored as x. It was not a terminating decimal, so I didn't want to round that, even though I wrote it on my paper that way. divided by the log of 1.0133. Make sure you close your parentheses every time, divided by 2. So that gives us that our time is, that came out pretty nice, 19 years. Anytime it's an application problem, you want to give the units. We're talking about the time. Time is always in years for these, for compounding interest. It's always years. Okay, so a little bit of a lengthy process, just with the setup and everything, but again, it's what we've been doing. There's just a context to it. Let's look at another one with time. This one, number 2, keyword here, continuously. So we're not using the same formula. This time we're using PERT. A equals PE to the RT. So let's look at the problem. The account balance gets to $17,063.35. So that is the left side of the equation. She invested, I'm assuming that's a she, might be a he. $6,495 is the investment, so that's P. E, remember, is the button on the calculator. It's not a variable. It's the value on the calculator. E to the R, the rate is 0.0743, and the question again is how long, so T is our variable. So similar to what we just dealt with, we need to get the exponential expression by itself. So we need to divide by the 6,495. And we need to store that as x because it's probably not a nice, pretty number. Yeah, 2.627. Yeah, I'm going to make a note that I stored that as x. All right, so exponential is by itself, so next step is log form. It's base E, so it's natural log. That's nice because now I don't have to worry about change of base. The natural log of 2.627, the number I have stored as x, is equal to 2.0743t. Again, nothing's really changed. This one's just a little bit easier computation-wise because you don't have the common log. We're using the natural log. So this one gives us about 13 years. Now let me show you, if you hadn't have stored that as x, your answer is not going to be that incredibly different. So here, if you have 3 digits after the decimal, like I wrote in the notes, 2.627, instead of storing it as x, it just doesn't give you 13.0000, it gives you 12.999, which if you ever get that, you can pretty much just assume that's supposed to be the whole number. So not the end of the world if you don't store it as x. I just think it simplifies things a little bit and you get a more exact answer. Any questions about those two? Finding out how long. Okay, let's look at 2 here where it asks about the interest rate. Norachai, fun name, invests $6,066 in a retirement account with fixed annual interest rate compounded continuously. There's another continuously, so we're using PERT again. After 17 years, so let's start filling in our equation. What is the interest rate? 17 years, it reaches that much. So same thing that we just did, we're just looking for R instead of T. And you're going to have to remember at the very end to convert that decimal to the percent form.